Welcome, dear friends, to Earth with Nature. Settle in, let your thoughts drift, and allow the weight of the day to melt away as we embark on a journey through time and space. Tonight, we're stepping back into the Mesozoic era, a time when Earth was a canvas of untamed wonder, painted with the bold strokes of dinosaurs, sprawling forests, and restless seas. But beyond the iconic giants, this was a planet in flux. Continents wandering, climates shifting, and life itself finding its rhythm in a world so different from our own. In this gentle documentary for sleep, we'll wander through the Triassic, Jurassic, and Cretaceous periods, not just to marvel at the creatures, but to feel the pulse of a younger Earth. Let's explore the raw beauty of our home's ancient past, while also pondering its place in the vast cosmic tapestry. Breathe deep, relax, and let's begin. Imagine, if you will, the Earth of 230 million years ago, at the dawn of the Triassic period. The supercontinent Pangaea stretches across the globe like a giant puzzle piece yet to be broken apart, its vast deserts and sparse vegetation baking under a relentless sun. The air hums with a strange stillness, interrupted only by the scurry of early reptiles and the first timid dinosaurs, no larger than modern dogs, testing their place in this harsh world. Picture yourself standing on the cracked, arid ground, the heat shimmering in waves around you. Can you feel the weight of a planet still finding its shape? This was a time of recovery after a devastating mass extinction, the Permian Catastrophe, which wiped out nearly 90% of life. Yet, Earth's resilience shone through, as new species like the agile Coelophysis emerged, darting through the scrublands. Science tells us this era saw the slow breakup of Pangaea, driven by tectonic forces deep beneath the crust, a process we now understand through plate tectonics, a field that revolutionized our grasp of Earth's history. These continental drifts, moving mere centimeters a year, were like the planet's heartbeat, reshaping landscapes over millions of years. As you imagine this alien Earth, consider, what does it mean for a world to endure such loss, only to bloom anew? Let that thought linger. Pause. Beyond just survival, the Triassic laid the groundwork for biodiversity, with early mammals hiding in the shadows and marine reptiles taking to the seas. It's a reminder of Earth's fragility, but also its stubborn creativity. And as we marvel at this, let's widen our gaze. Could other worlds out there, among the countless exoplanets discovered by telescopes like Kepler, have their own Triassic-like beginnings? The search for such places, part of planetary science facts we're uncovering daily, fuels our cosmic wonder. What kind of life might evolve on a distant planet with its own shifting continents? As we ponder this, let's drift forward in time to the next chapter of Earth's story, where the stage grows even grander. Fast forward to the Jurassic, around 200 to 145 million years ago, and the world transforms into a lush, humid paradise. Pangaea is fracturing, splitting into Laurasia in the north and Gondwana in the south, with oceans like the Tethys Sea carving new boundaries. Visualize towering conifer forests and sprawling fern meadows, their emerald greens stretching endlessly under a sky tinged with volcanic haze. The air is thick, warm, and alive with the bellows of giants. Think of the long-necked Brachiosaurus, its head grazing treetops 40 feet high, or the stealthy Allosaurus, stalking through the undergrowth. Can you hear the distant rumble of their steps, or smell the damp earth after a tropical rain? Science reveals through fossil records and isotopic analysis that this era had higher carbon dioxide levels, creating a greenhouse climate, much warmer than today with no polar ice caps. Technology like CT scanning of dinosaur bones shows us how these creatures adapted, their lightweight, hollow skeletons a marvel of natural engineering. But amidst this splendor, life was a delicate dance. Ecosystems teetered as predators and prey found balance. Reflect for a moment. How does a world sustain such giants, and what lessons can we draw from their eventual fall? Pause. This Jurassic Earth, vibrant and volatile, mirrors the fragility we study in exoplanet mysteries today. Astronomers, using tools like the James Webb Space Telescope, probe distant worlds for signs of atmospheres that might support life, wondering if they too host jungles or giants of their own. Earth's past, then, becomes a lens for imagining alien futures. It stirs a sense of awe, doesn't it? To think our planet's story is but one among billions in the universe, each with its own epochs of wonder. Let's carry this thought as we step into the final act of the Mesozoic, where Earth's drama reaches its peak. Enter the Cretaceous, from 145 to 66 million years ago, a time of both breathtaking diversity and looming change. The continents are more recognizable now, though still adrift. North America and Europe parting ways, South America and Africa slowly separating. Picture vast, flowery plains where the first blooms of angiosperms, flowering plants, add splashes of color, their scents drawing early insects. Above, the skies buzz with primitive birds, descendants of dinosaurs, while below, the mighty Tyrannosaurus rex reigns with jaws that could crush bone, as paleontology uncovers through biomechanical studies. Can you imagine standing in the shadow of such a beast, feeling the ground tremble? Or perhaps you're near a coastal swamp, watching a triceratops graze peacefully, its horns glinting in the sun. Climate data, pieced together from ancient sediment cores, shows a world still warm but cooling slightly, with seasons becoming more defined. This era saw Earth's biodiversity at a zenith, yet it was fragile, dependent on a balance soon to be shattered. Reflect quietly. What does it mean for a world to reach such heights, only to face an abrupt end? Pause. The asteroid impact that ended the Cretaceous, a 6-mile-wide rock slamming into what's now the Yucatan Peninsula, left the Chicxulub crater as evidence, a scar we've studied with seismic imaging and drilling tech. This event, wiping out 75% of species, including non-avian dinosaurs, teaches us about planetary vulnerability. Yet, it also sparks curiosity about cosmic wonder. Are other worlds out there scarred by similar cataclysms? Exoplanet research, using spectroscopy to analyze distant atmospheres, seeks signs of life that might have survived or emerged from such chaos. Earth's story, then, isn't just history. It's a blueprint for understanding life's tenacity across the stars. As we linger on this thought, let's zoom out to see how this ancient past connects to our place in the universe today. Now, as the landscapes of the Mesozoic fade into memory, let's lift our gaze beyond Earth to the broader canvas of the cosmos. Our planet, with its dramatic eras of dinosaurs and drifting continents, is but one world among trillions. Astronomy tells us the Milky Way alone may host billions of planets, many in the habitable zones of their stars, as discovered through missions like TESS, Transiting Exoplanet Survey Satellite. Imagine a distant exoplanet with its own Mesozoic-like era. Perhaps alien forests sway under twin suns, or creatures unlike any dinosaur roam alien plains? Can you picture such a place, and what stories its rocks might hold? Pause. Planetary science facts reveal that habitability hinges on delicate factors: temperature, water, atmospheric chemistry, all of which Earth balanced so beautifully, even through upheaval. Yet, studying exoplanet mysteries, we see how rare this balance might be. Worlds like Venus, once possibly habitable, turned into hellish ovens due to runaway greenhouse effects, a fate we've modeled with climate simulations. This fragility stirs wonder, not fear. Earth's journey through the Mesozoic shows life's persistence, its ability to adapt and thrive. It invites us to cherish our home while dreaming of others. What if we're not alone in this universe, but part of a vast network of worlds, each with its own history of struggle and beauty? Let this thought expand your mind as we near the end of our journey, connecting the ancient Earth to the infinite possibilities beyond. As we return to the present, let the echoes of the Mesozoic linger, a reminder of Earth's enduring spirit and its place in the cosmic story. Tonight, we've walked through ancient forests, stood beside towering dinosaurs, and pondered the shifting continents that shaped life itself. We've also reached for the stars, imagining exoplanets with their own tales of wonder. I hope this journey with Earth with nature has brought you peace, sparked curiosity, and filled you with awe for our planet's past and the universe's mysteries. If you've enjoyed this slow, reflective exploration of cosmic wonder and planetary science facts, please give this video a thumbs up. It helps others find these calming stories. Subscribe to Earth with Nature for more journeys through time and space, where we uncover exoplanet mysteries and celebrate Earth's beauty. And in the comments below, share your thoughts. What did you imagine while picturing the Mesozoic? Or what kind of alien world do you dream of? Let's keep this conversation alive. For now, rest easy, let your mind wander among the stars, and we'll meet again soon for another gentle adventure. Good night, friend. As the gentle whispers of the Mesozoic and the cosmic dreams of distant exoplanets settle into your mind, let's continue our journey by diving deeper into the aftermath of the Cretaceous extinction, a pivotal moment that reshaped Earth's destiny. Picture the world just after that catastrophic asteroid impact, 66 million years ago, when the skies darkened with ash and debris, plunging the planet into a chilling darkness often called the impact winter. The once thriving ecosystems of the late Cretaceous, with their towering Tyrannosaurus rex and armored Ankylosaurus, crumbled as sunlight was blocked, halting photosynthesis and collapsing food chains. Can you imagine the eerie silence of a world where the roars of dinosaurs no longer echoed, replaced by the rustle of surviving ferns and the faint scurries of small mammals? Scientific studies, using advanced modeling of atmospheric particulates and fossilized soot layers, estimate this darkness lasted months, if not years, with global temperatures dropping by as much as 26 degrees Celsius in some regions. Technology like mass spectrometry has helped analyze the iridium spike in rock layers, a rare element abundant in asteroids, confirming the Chicxulub impact as the trigger for this mass extinction. Beyond the immediate devastation, this event carved a path for new life. Tiny mammals, no larger than shrews, survived by burrowing and scavenging, their adaptability studied through dental microfossils revealing diets of insects and seeds. Reflect for a moment. What does it say about life's quiet strength that from such ruin, the ancestors of modern mammals, our own lineage, emerged? Pause. This resilience ties directly to our earlier musings on planetary fragility and cosmic wonder. Just as Earth rebuilt itself, could other worlds recover from their own cataclysms? Exoplanet research, leveraging data from the Hubble Space Telescope, probes for biosignatures like methane or oxygen in alien atmospheres, hinting at life's potential to endure elsewhere. Consider the parallels. Earth's post-extinction recovery, driven by slow geological processes like volcanic outgassing that restored the atmosphere, mirrors what we hypothesize for habitable zones on distant planets. Imagine a far-off world, scarred by its own asteroid strike, where life clings on in hidden niches, waiting for its moment to bloom. This thought weaves seamlessly into our narrative of Earth's Mesozoic saga, reminding us that destruction often sows seeds of renewal. As we ponder this, let's trace how these surviving creatures evolved, shaping a world that would one day be ours, while keeping our eyes on the stars for stories of similar rebirths. Let's explore the Paleogene period next, where the echoes of the dinosaurs fade, but their legacy lingers in unexpected ways, connecting directly to our reflections on life's tenacity across the universe. Stepping into the Paleogene from 66 to 23 million years ago, we witness Earth's slow healing, a direct continuation of the post-Cretaceous recovery that reshaped life after the asteroid's devastation. Visualize a world emerging from darkness, where the ash has settled, and the first rays of sunlight pierce through a still hazy sky, illuminating vast, empty landscapes once dominated by giants. The air feels lighter, cooler, as global temperatures stabilize, a shift confirmed by oxygen isotope analysis of ancient marine fossils showing a gradual climatic rebound. Small mammals, descendants of those Mesozoic survivors we pondered earlier, scurry through undergrowth, their tiny paws pattering across the ground now free of towering predators. Can you picture their beady eyes scanning for danger, or sense their cautious hope as they nibble on newly sprouting plants? Science reveals through phylogenetic studies that this era, particularly the Eocene epoch, saw an explosion of mammalian diversity. Early primates, ancestors of horses, and even whale precursors like Basilosaurus adapting to oceans, their evolutionary paths mapped via DNA sequencing and fossil morphology. Technology such as 3D imaging of skeletal remains shows how these creatures developed specialized traits, like the elongated limbs of early ungulates for running across open plains. This adaptive radiation directly ties to the Mesozoic's end, as the absence of dinosaurs opened ecological niches, a concept paleontologists call ecological release. Pause and reflect. How does it feel to know that the fall of one era birthed the rise of another, leading to us? Pause. Linking back to our cosmic musings, this rebirth parallels the search for life on exoplanets. Planetary science facts suggest worlds in the Goldilocks zone might undergo similar evolutionary bursts if cataclysms clear their slates. Missions like the upcoming Plato telescope aim to detect Earth-like planets, analyzing their light curves for signs of habitability. Could they host their own Paleogene-like recoveries? Imagine an alien world where, after a devastating impact, small, resilient life forms creep from the shadows, evolving into forms we can't yet fathom. This thought extends our narrative of Earth's fragility and wonder, reminding us that life's story, whether here or among the stars, is one of constant reinvention. As we linger on this, let's move forward to the Neogene, where Earth's landscapes and creatures grow more familiar, yet still whisper of ancient Mesozoic roots. while our gaze remains fixed on exoplanet mysteries for signs of parallel tale. Advancing to the Neogene from 23 to 2.6 million years ago, we see Earth's transformation continue, building directly on the mammalian dominance that emerged in the Paleogene after the Mesozoic giants fell. Picture sprawling grasslands replacing dense forests in many regions as tectonic shifts, still echoing the continental drift from Pangaea's breakup in the Triassic, raise mountain ranges like the Himalayas, altering global climate patterns. The air carries the scent of dry savanna, and the horizon ripples with herds of early horses and antelopes, their hooves thundering across open plains. Can you hear the distant trumpeting of early elephants, like Gomphotherium, or feel the warm breeze as it sweeps over these vast open spaces? Scientific research using carbon isotope analysis of fossilized teeth shows a dietary shift to grasses, driving the evolution of grazing animals, while climate modeling reveals a cooling trend as CO2 levels dropped, partly due to increased weathering of rising mountains. Technology like ground-penetrating radar has uncovered ancient migration routes, illustrating how these creatures adapted to changing environments. This era also saw the rise of early hominins in Africa, direct descendants of the primates from the Paleogene, their bipedal strides, studied via footprint fossils like those at Litoli, marking a step toward humanity. Reflect quietly. What does it mean to trace our roots back through such vast spans of time, from the shadow of dinosaurs to our first steps? Pause. Tying this to our earlier cosmic wonder, the Neogene story of adaptation mirrors what we seek in exoplanet mysteries. Could alien worlds, detected by spectroscopy for water vapor or oxygen, host their own evolutionary leaps in response to geological upheavals? Planetary science facts from missions like Kepler suggest many exoplanets orbit in zones where liquid water might exist, potentially fostering life that adapts as Earth's did. Imagine a distant savanna under a violet sky, where alien grazers evolve alongside rising alien mountains. Doesn't that stir a sense of connection across the cosmos? This builds on our narrative of Earth's journey from the Mesozoic through recovery and renewal, extending the thread of life's persistence to the stars. Let's carry this off forward as we approach the Quaternary, where Earth's story becomes our own, while still pondering if other worlds share such histories of change and survival. Entering the Quaternary from 2.6 million years ago to the present, we stand at the threshold of our own era, a direct extension of the evolutionary strides seen in the Neogene, rooted in the Mesozoic's distant legacy. Visualize Earth now shaped by ice ages, with massive glaciers carving valleys and retreating to reveal familiar continents, their positions a far cry from Pangaea's unified mass we first explored in the Triassic. The air bites with cold during glacial peaks, then warms as interglacial periods bloom, a cycle reconstructed through ice core samples from Greenland and Antarctica, revealing ancient CO2 and methane levels. Picture woolly mammoths trudging through snowy tundras, their shaggy coats swaying, or early humans, direct descendants of Neogene hominins, crafting stone tools beside flickering fires. Can you feel the chill of an ice age wind, or the warmth of that communal flame? Science, through radiocarbon dating and genetic analysis, traces human migration across continents, showing how Homo sapiens adapted to diverse climates, much like mammals adapted post-Cretaceous. Technology like satellite imaging maps ancient shorelines altered by melting ice, while genomic studies reveal our shared ancestry with extinct species like Neanderthals. This era, still unfolding, ties us to every chapter of Earth's past, from dinosaurs to savanna dwellers. Pause and think. How does it feel to be part of this continuum, a story millions of years in the making? Pause. Linking to our cosmic thread, the Quaternary's tale of adaptation and survival resonates with exoplanet mysteries. Planetary science facts suggest worlds detected by the James Webb Space Telescope might currently be in their own Quaternary, hosting intelligent life adapting to glacial or climatic shifts. Imagine an alien species under a different star, crafting their first tools as their planet warms. Could their story mirror ours? This extends our narrative of Earth's resilience from the Mesozoic's end to today, fueling wonder about life's universal potential. As we reflect on this, let's shift focus to humanity's role in shaping Earth now, while still dreaming of cosmic parallels on distant worlds. Turning our gaze to the present, often termed the Anthropocene, we see humanity's imprint on Earth as a direct continuation of the Quaternary's unfolding story, carrying forward the evolutionary legacy from the Mesozoic through every era we've explored. Picture sprawling cities gleaming under the sun, their steel and glass reflecting a world transformed by human hands, yet still bearing scars and beauty from ancient geological shifts like Pangaea's breakup. The air hums with the buzz of technology, but also carries the weight of pollution, a challenge studied through atmospheric chemistry revealing rising CO2 levels akin to the Jurassic's greenhouse warmth. Can you sense the hustle of modern life, yet feel the ancient Earth beneath your feet, whispering of dinosaurs and drifting continents? Science via climate models and satellite data shows how human activity accelerates changes. Deforestation, ocean warming, species loss, echoing mass extinctions like the Cretaceous event, though driven by us, not asteroids. Technology, from renewable energy innovations to carbon capture systems, offers hope, mapping ways to mimic Earth's past resilience, as seen in post-extinction recoveries. Reflect deeply. What responsibility do we bear, as stewards of a planet with such a storied past, to ensure its future? Pause. Tying this to our cosmic wonder, the Anthropocene raises questions about exoplanet mysteries. Could other intelligent species, detected perhaps by future radio telescopes scanning for technosignatures, face similar dilemmas of balancing progress with planetary health? Planetary science facts suggest many worlds might reach a stage of industrialization. Imagine an alien city altering its atmosphere, struggling as we do. This builds on our narrative of Earth's fragility from the Mesozoic to now, urging us to learn from history while pondering if cosmic neighbors share our challenges. Let's carry this thought as we explore how humanity might extend Earth's story beyond our planet, seeking connections in the stars. Looking forward, let's imagine humanity's next chapter as a direct extension of the Anthropocene, reaching beyond Earth while rooted in the Mesozoic to modern journey of resilience and adaptation we've traced. Visualize spacecraft piercing the atmosphere, their sleek forms carrying our dreams to Mars or beyond, seeking to plant life on barren worlds as Earth once bloomed after the Cretaceous darkness. The vacuum of space is silent, yet filled with possibility. Can you picture a future colony on a rusty Martian plain, or feel the thrill of discovering microbial life in Europa's subsurface ocean? Science, through missions like Perseverance rover sample collection on Mars, tests for ancient life via spectrometry, while projects like Starship aim to make interplanetary travel viable, echoing how tectonic shifts once opened new frontiers on Earth. Technology advances with AI-driven simulations of terraforming, modeling how to engineer atmospheres, much as volcanic activity reshaped Earth post-extinction. This drive ties directly to our story of life's persistence, from small mammals surviving asteroids to humans now reaching for the stars. Pause and consider. What does it mean for us, born of Earth's ancient struggles, to carry life's spark to new worlds? Pause. Linking to exoplanet mysteries, this future vision connects to cosmic wonder. Planetary science facts from exoplanet surveys suggest thousands of worlds could be terraformed if we master the tech. Imagine seeding life on a distant planet, mirroring Earth's recovery eras. Could we one day meet alien species who've done the same? Their history echoing ours from Mesozoic-like beginnings to spacefaring dreams. This extends our narrative of Earth's evolving tale, inspiring awe at life's potential to spread across the cosmos. As we ponder this, let's close with a reflection on how every step, from ancient dinosaurs to future colonies, weaves a single thread of wonder and responsibility. Finally, as we stand at the edge of Earth's past and humanity's future, let's tie every chapter, from the Mesozoic's towering dinosaurs to dreams of Martian colonies, into a unified story of endurance and curiosity, directly building on all we've explored. Picture yourself gazing at a night sky, the same sky that watched over Brachiosaurus in the Jurassic, early humans in the Quaternary, and now us dreaming of the stars. Each twinkling light might hide a world with its own history of cataclysms and recoveries. Can you feel the weight of connection, the shared pulse of life across time and space? Science, through tools like the upcoming Vera C. Rubin Observatory, will soon map millions of exoplanets, refining our understanding of habitability with data on stellar radiation and orbital dynamics. Technology, from quantum computing to interstellar probes like Breakthrough Starshot, pushes us closer to answering if we're alone, much as paleontology pieced together Earth's Mesozoic past. This quest mirrors the resilience we've traced, from post-Cretaceous survivors to modern explorers. Reflect one last time. How does it feel to be part of a story so vast, from Earth's first stirrings to the cosmic unknown? Pause. Our narrative of cosmic wonder and planetary science facts culminates here, in awe of Earth's journey and the exoplanet mysteries awaiting us. Imagine a future where we learn of alien worlds with their own dinosaur eras, their own recoveries. Doesn't that ignite a boundless sense of possibility? As we've walked through time, from shifting continents to starbound dreams, let this wonder linger. If this journey with Earth with nature has stirred your soul, like and subscribe for more tales of Earth and beyond, and share in the comments what future or alien world you envision. For now, rest with these thoughts, knowing our story, from Mesozoic giants to cosmic frontiers, is still being written, and you're a vital part of it. Good night, dreamers of worlds near and far.